All right, hey everyone, I'm David Room. Today we're going to be doing some more low poly spacecraft modeling with Python code. Uh, and we're going to be picking up kind of where we left off last time, working on some interesting things related to some new techniques that I'm building and introducing into the process. So let me just share the link on Twitter now that I'm live, and then we will get right into it. So, um, so last time we were looking at a method to create these kind of shrouds or armored sections over ships using a method where we would take cross sections, and I'll kind of illustrate how that works here in a second. But I ran into an interesting issue um, where I didn't have the right building blocks I needed to actually use this method. So we got as far as making nice cross sections using alpha shape to make sort of a fluid uh, kind of soft, maybe shrink wrap like outline around the mesh. But I was missing a kind of an important piece of functionality that I actually worked a lot on over the weekend and got up and running. So let's take a look at that now. Let me share my screen here. And let's see here. Okay, so actually, let me just go back to the camera for a second. Got to close out some windows. Um, okay, so just a little bit of background. Um, so, let's see what I have it here. So one of the friends of the channel or viewers had talked about the idea of enclosing the spaceship's drives in a streamlined body, because my spacecraft that I built in the world that uh, the game that I'm building and all my projects are set in, they're not like rocket engines. They are sort of these magic drives that kind of interact with this. Um, it's actually called ether, that sort of sits behind in a hidden dimension behind the world. And it would be possible to enclose these drives in different ways and still have them function. So he kind of is asking about seeing an armored version of the ships, and I mentioned that shrouds are definitely a thing. So we started in on this, and I'll bring up the ship. So I've been working a lot on a design called the Ashinoko, and what I'd actually like to do is maybe finish with what I'm doing on this design relating to this armor stuff and actually go on to a different one. But the Ashinoko looks like this. So we have these this kind of radial symmetry, and we have these three large drives at the back. So the idea would be, what would it look like if there was some kind of curved shroud that kind of enclosed these drives? So we started on a method where we first take the ship and we kind of strip out components that we don't want to be part of this shroud that we're going to create. So I've tossed out the radiators and antennas and different things like that. And then we take slices. So here's kind of a visualization of the slices that I'm currently taking. I tweaked this a little bit the other night. I'm still kind of figuring out the workflow for this approach. It's new, and we'll actually tweak this visualization here in a second so we can see what's going on better. But we're going to take these slices, and then for each of the slices, we're going to come up with a rib or a sort of outline, and then we're going to bridge all of these loops together to come up with a surface. So this is kind of what the latest version of it looks like. And we've got a little bit of extra geometry here, and maybe we need another piece of geometry here. I'm still kind of figuring this out, but I want to keep the look of the low poly ships. I don't want to break that too much with this functionality. And there are a lot of faces here. There's 219 faces in this shape. Some of that is unavoidable, like with the shape around the drives, but I'd like to cut that down if possible. And some of these here aren't really doing a whole lot, so we're going to take a look at that. So yeah, let's jump in. Here's what it looks like actually on the ship. And I mean, this isn't necessarily like the greatest thing in the world, but it was sort of a nice proof of concept, and I think there's some things that we can do to make this look better. It's also going to look more balanced and less back heavy once we get the radiators back on there. So let's jump into this and see how far we can get. We can kind of figure out this new workflow together. So yeah, let me actually get some music going. My White Bat Audio playlist that I like to listen to. And we'll get going here. So, it's really unfortunate that I'm generally not opposed to IP laws, but it's kind of unfortunate that the music industry is especially such a stickler about copyright. You know, you can live stream all the video games that you want, but it would be really a lot of fun if you could just live stream arbitrary music and nobody cared. That would make streaming a lot more fun. Okay. And just gotta tweak my brightness here a little bit too. Okay, so the first thing I'm gonna do here is I'm gonna make these slices a little bit bigger so we can see what's going on. So what I'm doing right now is I'm taking these slices and I'm deriving these shapes from them, and then I'm tweaking their positions along the y-axis a little bit. But what I actually want to do instead is I just want to take some arbitrary slices and then put them in more arbitrary spots to build the shroud. So that's what we're going to try. And I'd like to get as far as actually getting this in the game engine to see how it looks. I'm not exactly sure how this is going to actually look in the game engine, and I'd like to get as far as seeing that. So you can see one of the issues that's creating that extra geometry is this slice that we're taking is kind of cutting through this stuff here. So what I think I'm actually going to do is I'm actually just going to use I think I can actually just use one of these instead of this one. And I'm actually, there's another thing that's really annoying. I've got to disable this visualization. So I'm viewing this case where retriangulation isn't working like right. And I want to disable that. So I'm just going to add a constant here. So I want to have to be this explicit about disabling this, because normally I want to know. But I'm tired of looking at it. Oh, nice. Michael Kane is here. He says, dropping in for a few. This is way outside my wheelhouse, but I've got you in the background for now. Nice. Well, I hope to be good background. I think that I know personally I really enjoy having kind of a set of friendly, creative people who do live streams that I can put on the background, and that's actually one of the reasons I like to stream, is because I kind of want to pay that forward. Having those people is a really big it's a really big deal to me, and something that's important in my life. So absolutely put me on in the background. Okay, so we're gonna actually disable this. This is kind of obtuse, but I want to have to go out of my way to disable that. Yeah, see, because this rib doesn't really look that much different. I'm actually outsetting things a little bit, so it won't really matter if there's some little bit of size differences. So we've got a question here. Prince Uo Frederick says, what IDE is this? PyCharm, PyJar, or VS Code? I'm not sure what PyJar is, but this is PyCharm. So I strongly prefer PyCharm to VS Code for many reasons. Okay. So here's where I'm finding, slicing, finding the alpha shape, and then giving it a negative inset. So here's kind of where we're shuffling things around. And I think what I want to do instead of this, like I was describing, is I just want to sort of choose positions and then move them to where I want arbitrarily. I think that would be easier to reason about than this. So and I'm going to assign these to some more descriptive variable names so I don't lose track of what they are. So we're going to call this something I find is when I get like really confused about something and I kind of have trouble tracking what's going on, it's a sign that I need to refactor, do things differently, rename things. So that's what I'm going to try to do here. So this is going to be drive min y plus 1, drive end y equals drive max y minus 1. And then piece y is going to be this one. Plus 12. Okay. Now we can rewrite where we want these slices. So we're just going to do some arbitrary slices and then move them different places. So drive end y piece y, and then what I was thinking, so we're gonna get rid of this tweak stuff. What I was thinking is it looked like I could just use something like this as for a couple of different ribs in the middle. Tweak. Okay, so now we're gonna build two. So build from this, and we can trivially remove the original y's. So what I'm going to do is actually destructure this, and I'm going to rename this too. So we'll do drive middle. We'll call this drive middle y. Okay, so we've got 4 of these: start, middle, end, and fuselage. And then what we'll do is we will, right here, we'll rip the y dimension out. Oh, my nose is itchy. Geez. Okay. We'll rip the y dimension out. And then we can plot these as 2D. And then we will destructure them back into named variables so we can keep track of what we're actually doing here. Okay, so just add a rib prefix. We'll just exit here for now. Okay, so here's where we're taking from. This one we're going to have to shift forward farther, I think. Yeah. Yep. Okay, so yeah, the nice thing though is now that's easy to reason about. Giving these things names really helped. Okay. Yeah, that's what we're looking for, because we're looking for a spot that doesn't have extra geometry. So here's what we're gonna do now. So now we can build our set of ribs, and these should all be going counterclockwise. So we want to arrange them, I believe, front to back. Let me just look at my test. We're attaching Y. Yeah, we want to go front to back. So we can attach a Y coordinate. This. And then we're going to try just repeatedly using this middle one. So with actually, yeah. And actually, let's start. And actually, we will try keeping that. Okay, so now we have to adjust our Y coordinates. So here we'll do, and say like -2. Yeah, this is much better. Actually, let's do 4, just to give ourselves a little room, and then see what it does. Why is my semantic highlighting up? Okay. There we go. Okay. Yes, that is what I was picturing. So basically we have 2 of the same rib, and then one slightly different one, which I think we can actually use one of these instead. Just actually swap that in there, and we can get rid of this one. And then now we can actually build it. Let's see what it looks like. And I'm just going to clean something up. We don't need this ribs unscaled language anymore, because that was coming from the thing. Yeah, see, and then see, now we're down to 150 faces. So that is more like what I was hoping for. We don't have this extra geometry. And it still is enclosing it. Looking good. Now what I want to see is if we can add an extra rib in here that kind of bridges this, so we don't have just a straight kind of flat surface here, but we have something that's got a little bit more visual interest to it. And if we do that right, let me just look at this. The other thing that we might be able to do is yeah, we can't really get away without having that right there. Okay, so let's try this. So just give this a simple little scale factor and adjust this back. Like this. Also outset it. Yeah, see? So you don't actually want it scaled up because that does that. We want something, we want to actually interpolate, right? We want to somehow interpolate. That would be a fun thing to try to implement. How we would come up with a rib that sort of interpolates. A trivial thing we could do is we could slice this thing, do the alpha shape on it, and then tweak it. I'm wondering if there's a better way. Maybe that is the best way. Should we try it? See what we come up with. It's kind of silly, but it might do what we want. Okay, so let me think about this a little bit more. Do I actually want another rib in there? I don't know if I really do. Because that would add a lot. That would add a lot more vertices. We already have a lot. I don't want this thing to get too complicated. And what I want, I can't really interpolate, because what I want is I want something I want something that comes out. Yeah, okay, I need to think carefully about what I want here. I want something that comes out farther here, right? And then slopes in. So what would that do here? It would... Would it transition and start coming out earlier here? Or would it stay in? I think it would stay in here. But this would come out more. Let me just look at what's going on underneath here once. See, it's got room. I don't know. Maybe I'm overthinking this. Maybe this is just pretty good as is. Let's factor this into a function where we can add it to the ship and see how it looks in engine, and then if we feel like we still want to do more with it, then we can. But I'm kind of thinking I probably shouldn't mess with it too much more before we know that. So let's open this up. Let's call this shroud. Oh, nice. Oh, it's good to see you there, Jupiter BJY. Are you asking what Ashnoko is, like where the name comes from? I know we were talking the other day about the sources of the names for my ships, and he says, hey, good to catch you. What's Ashnoko, by the way? If you're asking where the name comes from, it's the name of a lake in Japan, in a place called Hakone, and it is a really beautiful place. I've actually been there, and I found out later after I was there that Hakone is also the place where Evangelion takes place. So a lot of the kind of interesting scenery and geography in Evangelion is around this place. And Evangelion isn't really a direct inspiration for my stuff, but it's kind of coming from some of the same places. So that's kind of the reference. And I think I was kind of thinking that the lake itself sort of is the same shape as the ship too, because it's kind of a long, narrow lake. See if this works. I'll clean it up. Whoops. Gotta import some stuff here. Clean up all these extra ports and crap. Just looking at my imports here, I think traceback is just a built-in. Okay, so that doesn't. Let's get rid of some of these extra visualizations here. This variable. To clean up this awful kind of experimental code now. Eventually I'll move these things out to constants, to be like module level constants, but for now they can just kind of hang out here. Can redo these as offsets if necessary. Oh, let's see here. Yeah, I'm not even using these anymore. Okay, so And this should end up being in the global coordinate system of the ship, which should be fine. So yeah, Jupiter BJY, I don't know if you caught it, if you're still watching, but I'm actually working on something that you had commented about, which is shrouds or armored parts on ships. It's something I've been thinking about for a long time, and your comment kind of inspired me to take it on, and I built a cool algorithm for bridging edge loops, which I'm a little bit out of it this week, so I'm not going to actually talk through how it works tonight. Man, that was a pain to come up with something, and it's still, you know, maybe not, probably there's a lot of situations where it wouldn't work, but it has some nice properties that make it work well for this kind of low poly stuff, so I'm pretty excited about it. It's something that I should be able to use for a lot of different things. Even just adding a little bit of extra detail to a lot of the ship models, I think it'll be great for. So, okay. And let's see, we gotta update our return type here. Okay. Okay, so now that we have this, what we can actually do is update the model, the ship model itself, to include the armor. So let's do that here. So when we So here's our result. We can get the armor here from, or the shroud, using the consistent terminology, and we'll actually make this private too. So we'll just add this in as a new part. And I think we can, yeah, because there's no offset to the root, so we can just add it as a child of the fuselage here. And then what we're going to have to play with is the smoothing. So let's just try something like 30 first. Let's see what that gets us. And just to make sure that this is actually running, still, I thought I disabled that that stuff. Okay. Now we just got to look at the definition for the ship in the game. And we'll add in an exclude for dumb. Okay, and let's fix that other stuff here. Let's see here. Is it use? What is that function? Triangulate. Got it. turn that off. And I thought, oh, maybe I, yeah. So here in the YAML, we're excluding the shroud. And we'll add in a model info for it. So and I think by default this should end up being the same color as the fuselage, but we might have to tweak the livery too if it ends up being white. Actually, let's just preemptively do that. So our first look at it in engine, it isn't just a complete eyesore. It right, because let's see here. Oh yeah, drive system. And actually, these are gonna be the chiller. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 3, 4, 5, 6, 7, 8, 9. So this is actually going to be 10. Markings is, yeah. Yeah, so this the shroud is going to be number 10. Alright, should we see if it loads? Yeah, look at that. There it is. And that looks almost exactly like I was expecting it would. Now, there's some things that we obviously need to fix here. So it needs to be double-sided. And then we probably want to shrink that gap down and also cut some holes in it for the radiators. But other than that, it actually looks really good. Let me just see here. Yeah. Yep, this is the enclosed drives. There's some other designs that I wanna try this on as well. Yeah, okay, let's see if we can fix the double-sided thing. Sided. Just gotta remember how I do make stuff double-sided. I think. Let's Let's see here. I think. Is it two-sided? The props is two-sided. Yeah. So let's fix that. Yeah, there it is. Nice. That looks pretty good. Now, what I'm going to do next is I'm going to tighten up that gap in the front. Let's do that. So, set mount. So basically, if index is less than, so we have 4 of these, right? 0, 1, 2, 3. Index is less than 3, then we do the outset. Oops. Jupiter BJY says, so much interesting things I wish to watch in detail, but watching or even listening is quite tricky outside. Well, guess I should return from my company lunch break. I'm sorry to hear that, but you can always watch later, and I appreciate the watch time anytime, and I appreciate all of your comments that you leave, so I'm glad that you could stop by. We should try to find a time sometime, and maybe it's me streaming on my lunch break or something, when you can hang out. It was really fun the last time that you stopped by and you were like helping me watching what I was doing wrong. I really like pair programming in real life, and I don't get to do it at my job anymore, so it's kind of fun to be able to do that. Thanks for stopping by. Yeah. Okay, so that does cause a little bit of intersection there. Maybe maybe a little bit less of an inset. So like if index is less than 3, we do it. Otherwise, we do like half the inset amount or something. Yeah, that looks pretty good. Let's see. Trying to think. Cause see what I just need to remove that face, and that would actually give me my gap for the radiators without causing any other like weird shading issues or anything. Let's see if we can actually just programmatically do that quick. So, and then we'd be in a good spot with this. So, oh, I never actually did this either. Wait a second. What am I? So we want to actually process this here. Process. That should, we have 153. Yeah, that drastically reduces the number of vertices. Okay, and then yeah, let's think about this. So we want to remove the faces that the radiators intersect. Okay, so how can we do this? Well, we can find the we can make rays that intersect, and we can make these rays be the I think it's the x coordinate of the radiators. Let's see if we can do this quick. So ray. This is going to be something like 0, and then our drive middle y 0 for the point that the ray comes from, and normal. I need to rename that. It shouldn't be normal. Should be something else. But the direction is going to be a dot square. So it's going to be a part dot. Yeah, because the long dimension is the x. That's rad. Okay, so now we're going to intersect. And I think this should return. I'm tossing out the face indices. Oh, I can do fine proximity. That'll give me it. That's kind of the same. That kind of gives me the same thing. So find proximity. Yeah, because that gives points, distances, and triangle. So it's here. Points. Face. Indices. And so we can get rid of this ray nonsense. Just have normals. Yeah. I'm gonna keep this guy just for reference. Center. And that's just equivalent to this. Okay. And then normals is gonna be still be this. Equals center plus some nice big number, 10 meters or something, times x. Proximity. Shroud. Nice. At some point I had a nice viewer where I could view mesh points. View mesh points. Yeah, look at that. It's right in this module. Oops. Okay, so red isn't it. Oh, I need to grab these out of parts work. Oh, okay. Wrong mesh. But it looks like it was working. So, yeah. So now I can find the facets, and I can find the facets that these faces belong to and toss them. So, select dot. Let's see here. Subset mesh faces. Okay, let's grab all the facets. Facets. Select dot facets all from shroud. No. So facets is going to be a list of lists of face indices. So what we want to do is like find the facets that don't contain any of the face. Let's see what's like points face. There's probably more efficient ways to do this, but it's okay. Centered. Facets. In let's see this index face facet, then true, break, and if found, then continue. Actually, if not found, I think that's a little clearer. Then facets filtered. So I might already have a function that does something like this, but it's not too big of a deal to rewrite. And then select delay. Can I? Yep. So faces keep now is going to be faces keep is going to be basically a flat list of facets filtered for X in facets filtered for Y and X, and I think that should be already unique, but let's just make sure. And then shroud equals select dot subset mesh faces shroud and faces keep. Okay. Let's see if this does it. Yeah, look at that. Boom. Now, if I cared to add an extra, I could just add another ribbon here just to get rid of that extra gap. Or I could add if I didn't care about the connectivity, I could fix this in some different ways. Well, let's just see how this looks. I think it'll probably look pretty good. Excuse me. Okay. Yeah, that looks pretty sweet. There's a number of different things. There's a number of different things you could do. Actually, let me just getting an idea just looking at this here. I could also take off this thing, right? I could take off this rear piece. That would look kind of cool. And that kind of makes sense because there's some parts under there that would actually make sense to have exposed. Maybe. Let's try that. So actually, we can just add a couple of additional rays here. and additional points. So just call this normals A. This B. We're going to do something similar. Actually, can we just... Let's try this. So actually, turn this to 20. And can I do this in a clever way? So we've got normals that are going around, right? Can I rotate them with itself crossed with Y? I think so. Let's try this. So the idea is we have these three normals that are pointing out that we're using to find points that we're going to project back to select. So if I cross each one with the y-axis, that gives us the direction, the axis that we need to rotate it to, like pivot it back to point at that other face that we want to select. So let's try that. So we're going to and you know what? We don't even it's not even that complicated. We just need to add some negative y to each one, and that will move it back. So all we have to do is normalize x plus x minus y hat. Yeah. See how we did that? Look at that. Nice. Now that looks pretty cool. Yeah. That looks good. And the shading looks really good here too. There's a lot of symmetry in how this thing is triangulated due to the way that I implemented my edge loop bridging. So it looks great. I'm pretty pleased with this. I think I'm gonna call it here for tonight. But we got some really good headway made on this, and it's kind of fun coming up with sort of a new workflow. When I've been working with the same tools for so long, having a new way to generate shapes pretty easily and programmatically is exciting. So I have some other stuff coming up that I'd like to do some streams on, so keep an eye out for it. One thing that I'm going to be working on pretty soon is 3D printing designs, and I have a lot of different utilities and things kind of related to 3D mesh processing that I need to build out to be able to do that effectively. And I think some of that would be nice, easy stuff to stream about and kind of interesting. And there's going to be more complex stuff involved once we actually get into 3D printing connectors. And I have some ideas about how to automatically design connectors like pegs and slots and things to fit the different parts into for 3D printing. And then another thing is some tweaks to the coordinate systems on different parts that I have. And also, and this kind of goes along actually with the shrouds, is for a long time I've been intending to actually give the drives of my ships these glowing parts. They're not rocket engines, but I think they kind of need some kind of marking that glows. And we have markings, we have emissive materials, we have all the tools that we need to do that. So I think it's a good next step. So if I don't do that on stream, those are all things that I'll show and talk about on stream, because I think they're going to be really nice changes. But thanks to everybody who tuned in, and see you later.